Hello, I'm Caroline Clifford. I'm about to have you embark on a new experience with the online class you're about to take. I teach in energy and mineral engineering, but I also teach classes in ag sciences, and my research is involved with coal and biomass conversion to liquid fuels.
I'm Jonathan Matthews. I'm an associate professor in energy and mineral engineering. I teach energy engineering with my colleague Dr. Clifford, and I also do engage in coal research. So the ethanol question is interesting. It comes down to location and source. Sugarcane-derived ethanol is actually very useful. It's much easier to process, it has a much greater energy content, it doesn't require the same inputs. Corn-derived ethanol, however, is more challenging. It certainly makes sense in the Midwest, however it doesn't make a lot of sense if you make it in the Midwest, then ship it all over the United States, forcing it into existing gasoline supplies. So the problem with ethanol derived by corn is it's less efficient process, you get much less ethanol, and also there are challenges with fertilizer and shipping costs.
Well, I agree with most of your assessment, Dr. Matthews, but with corn ethanol, it has come a long way in that it is improving with its net energy benefit ratio, in that if you have a net energy benefit ratio that is less than 1, you have a big problem. And for now, net energy benefit ratio of ethanol from corn is about 1.5 to 2. Part of the reason behind that is because they have been using biomass as part of the processing, along with coal, to try to reduce the coal issues in the atmosphere. And I will be explaining the net energy benefit ratio later on in the semester.
So there's a significant challenge in firing pure ethanol. It's mitigated by blending it with gasoline. So typically when I buy gasoline, it may have up to 10% ethanol by volume. So ethanol is slightly corrosive to some of the metal components. It also dissolves and attacks some of the rubber components and the seals in the engine, so that is troublesome. But blended in, mostly with the modern vehicle, you should be fine.
Some of the issue with using ethanol, again, from the perspective of Dr. Matthews, 100% could be damaging to your vehicle. In some of the older vehicles, even when blended with gasoline, there was an issue with it damaging some of the seals that were involved and some of the being corrosive to some of the metals. However, recently, the car manufacturers have accounted for this, and they have made cars that are specifically designed so that you can have ethanol in your sample. And as far as using ethanol in vehicles, we are currently in this country using 10% of our fuel as ethanol.
So we can certainly make biodiesel from biomass, and jet fuel would be a smaller chain hydrocarbon. So with processing, that's certainly possible. However, it's probably much easier just to get this from distilling crude oil and going through the usual routes, or even going through a gasification route with coal to make synthesis gas and produce jet fuel from that process. So can it be done? Yes. It certainly wouldn't be ethanol. Energy density is too low. It has handling problems with cold temperatures that would be required. So you need very different molecules in jet fuel.
Again, I agree with Dr. Matthews from the perspective of ethanol is not a very good fuel to use for jet fuel. And there is the option of biodiesel, but biodiesel does have a problem in that it has a certain chemical structure in it that you have to minimize for jet fuel because it can cause problems with making the fuel gum up. However, refineries and biomass refiners are looking at ways to try to introduce materials into a refinery in order to make a jet fuel that would be usable and would not have to go through the process of doing gasification and then Fischer-Tropsch synthesis in order to make a jet fuel.
So this jet fuel from biomass, quite frankly, is stupid.
Why do you think it's stupid, Dr. Matthews? I totally disagree with you.
We get jet fuel perfectly well from existing infrastructure. We can get it from crude oil. There's a possibility of making it from natural gas, which we have an abundance of right now. And we could even do it from coal, which would be lovely. Why bother with biomass?
Because biomass has the advantage of being CO2 neutral, or at least almost CO2 neutral. And if we're looking to make changes in our environment, trying to use something other than petroleum or natural gas or coal, which are all fossil fuels, would be beneficial. And we might be able to grow our own and not have to worry if there's any energy security issues.
Yep, so what you want to do, replace nice cheap jet fuel with really, really, really expensive biomass, and only the rich can fly. Shame on you.
Oh my goodness, Dr. Matthews, stop it. You know better than that.
Well, it's true. Fossil fuels are cheap, and it's excellent, and it helps the world.
Well, the fossil fuels being cheap have caused the problems to begin with. So we need to do something to mitigate the problems that have been caused by fossil fuels and putting too much CO2 into the atmosphere.
Fine. So, coal is absolutely fabulous, and all this talk about anti-coal is silly. Let me tell you what coal does. Coal is cheap, it gives you guaranteed available electricity, something the renewables struggle with the exception of hydro, and also it enables the economy to move forward. So if you want to start moving over to this green economy and having all this bloody renewables, be prepared to pay a lot more for it, and just because it's renewable doesn't mean it's free.
From the experience that I have been dealing with in converting coal and biomass into liquid fuels, I think that biomass has a greater opportunity in the long run, and it is because of the environment. That doesn't mean getting rid of all fossil fuels. It means trying to find a way to utilize both and to find a way to make it cheaper to make the biofuel. That's where we're going with that.